Next, you will see the world's most luxurious cars competing in safety, airbags turning into hot air balloons, orange flames lighting up the cabin. How Japan's craftsmanship spirit transforms into a stream of Ganges water, how a well-protected fuel tank turns into a fountain, 97 seasoned on-site Chinese brand technical test members in the cabin of a super top luxury car. Welcome to the large-scale automotive safety customer program Dongchedi Experimental Field. After 2 years, we're back online. In the past, we crashed dozens of cars one-on-one. Everyone said the collision combinations were too random, becoming large. Fixed test targets and fixed test combinations were needed. So we drove a truck through the wreckage of 2022 and resumed the 27-year collision test standards. Budget is limited and can't be extravagant, so this time we bring 30 models and 60 new cars. 2 cars per model including Chinese brands, joint ventures, imported cars, from million-yuan luxury cars down to 50,000 entry-level ones, covering a broader range with a larger scale and an annual cumulative sales volume of over 3 million. All cars are randomly purchased from the market for inspection without prior notice, led by a national-level testing agency, referencing international collision standards with the entire test process recorded fairly, impartially, and openly. These models will face the same opponents, such as the deformable frontal barrier, our under 1.4-ton friend test car, and the Road King, a 40-ton heavy truck. But we didn't expect many problems to explode in these tests, including family-style designs nearly disintegrated after collisions. Some models lost power after being hit by low-voltage electricity, and some models showed large-scale weld point failures during collision tests, and it was an imported car. This is also a major result to be revealed in this episode of Dongchedi Experimental Field. Now we are doing pre-collision preparations. Both plug-in hybrids and fuel cars need to discharge fluids and inject different colored dyes accordingly. This way, if the vehicle leaks, we know which part has the leak. For pure electric vehicles, we don't discharge disaster prevention batteries but set battery levels to about 50%. The National Third-Party Quality Inspection Agency, Beijing Product Supervision and Inspection Center, is responsible for the samples sent. It's a long process, but every step must be very careful and serious. Each car undergoes various inspections, a full workflow sheet and confirmation sheets. Before collision, we seal the fuel tank with stickers. The first test of Dongchedi Safety Index is the most basic 40% offset collision. After 100 milliseconds, an accident will occur. The car's structure, transportation system, and airbags become key points. Can they ensure my safety and that of other occupants? These 30 models will have a female dummy in the front row, 2 male dummies in the back row, and if there is a third row, 2 more male dummies will be added, configured to the vehicle's rated load. Because of its known reproducibility and strong repeatability since being introduced globally in 1997, over 27 years, automakers have done countless R&D on this, ranging from very poor to very good. It has become basic knowledge after ASEAN, North America, and Latin America collision tests. Performance improvement in this test contributes greatly to automotive safety enhancement. The collision target is a frontal variable deformable barrier. The honeycomb barrier simulates the small car's front cabin area, with a rigid barrier behind simulating a self-assembly. This test is mandatory globally and unavoidable for Chinese cars going abroad, testing automakers' fundamentals. We will test this car fully loaded. We also examine whether the vehicle's SOS hazard lights and doors can automatically unlock after collision. Most importantly, how does the structure perform? How are the occupant injuries? Is the car too hard to save lives or too soft and gets crushed? The final result depends on the test. The 30 models cover popular mid-range and entry-level cars. Let's see how these cars perform in this benchmark test. In the mature 40% offset basic test, is automotive safety performance proportional to price? First, let's look at the luxurious cars purchased at huge costs. The prestigious Maybach S, pioneering luxury SUV with full momentum, the Land Rover Range Rover, and the highly desired Mercedes-Benz G-Class. Also, luxury car sales leaders BMW X5 and Mercedes JRC. The total cost of these 5 cars can buy 47 BYD Song DMIs, which are doing basic offset collisions. Will they undoubtedly become the benchmark of this test or just fancy facades? These luxury cars gathered here provide a good reference for comparing Chinese brands with top luxury car safety levels. The first car has a large beam supporting the body, hard and solid, priced nearly 1.7 million yuan, brand new in Arctic white. Compared to crashing into a truck, the white Mercedes G-Class's offset collision is like a soup stirring water. Our honeycomb barrier structure is consistent across vehicles. Its crush absorption capacity is relatively fixed. For heavier cars, the honeycomb barrier easily causes a phenomenon called penetration, requiring the car itself to absorb related kinetic energy. Let's see if the analyzer matches its value. For this non-carrying SUV, it also poses a challenge. Let's see the results. This is the most severe fluid spray ever seen. Imagine this is scalding engine oil. Is there SOS? No. Hazard lights? Yes. The second battery is normal. The gap has obviously widened, including the A-pillar, which is deformed. These are close together. After the collision, the Mercedes deformed in the 40% offset collision. Let's see the door opening. It took a little long, but no obstacles opening the door. The chest injury values of the two male rear dummies already exceeded acceptable levels, possibly fractures. The injury score for death risk is the highest. Spending so much money on this car's safety performance cannot be said to be top-notch. Some may feel uncomfortable psychologically. The protection Mercedes offers to the poor is far below expectations. One of men's favorite models, the Land Rover Range Rover, is it as tough as it looks? The Land Rover Range Rover has an advanced steel-aluminum mixed unibody design, supposedly safer. It's a favorite of celebrities, priced at $1.63 million, and is the heaviest among our test cars at 3,345 kg. Go! The honeycomb barrier penetrated. This car's airbags and side airbags did not deploy. The whole restraint system looks simple, as if the car has few configurations. If you are frugal, what use are the remaining side curtains? Maybe it thinks its condition is too good and doesn't need them. The passenger airbag of the Land Rover Range Rover ignited a flame, the first fire in the offset collision. The rear dummy's seatbelt is mostly around the waist. Let's see the dummy injuries. Mr. Huang, this rear left chest injury is significantly beyond what a normal person can tolerate. Your chest was pushed in 7 cm, possibly breaking several ribs, potentially stabbing your heart and lungs, greatly increasing death risk. The rear right boss seat chest injury value was also high. We noticed both seatbelts were loose, indicating a seatbelt problem. It's really similar to cars costing tens of thousands, proving that Huang Shunrong is not necessarily a good investment. Can Range Rover, the pioneer of luxury SUVs, be the benchmark? This result is really no way around. If this happened in real life, 3 ambulances would rush over. The seriously injured dummies would want to escape to the Mercedes G but can't. They now need to board the Mercedes JRC, but JRC starts to show unexpected problems. The blue color represents scalding engine oil now spreading on the ground. In a real accident, this could ignite. The restraint system has some defects. The passenger airbag again ignited a flame. You can see a big bright fire inside the car immediately after the crash, like a rocket launch, posing burn and scalding risks. Previously, unexpected airbag explosions caused many recalls and other issues. This high-temperature flame poses burn risks. The overseas Mercedes GLC of the same model did not catch fire. Has this fireball ever appeared in Mercedes labs? Does Mercedes quality control allow such fires? BMW X5 structure and rescue are good but downgraded due to front seat airbag removal. The front female dummy's lower leg injury exceeded limits, resulting in a poor rating. The domestic BMW X5 lacks airbags standard in the US version. This is the cost of downgrade. Luxury cars are not perfect. Are luxury cars really good or not? Checking for broken ribs and leg injuries on Maybach S dummies. Can they breathe a little easier? This is the first public collision test for the Maybach S. It also equips rear airbags. We will see how well the rear airbags protect. Now the door handle pops out. On this side, you've been in a traffic accident. Would you like to call the police? Hello, can you hear me, sir? It's okay, I accidentally triggered SOS. It's normal. Low voltage power is normal. Hazard lights are normal. The rear airbag hardly touched. The heavy beam protection is not very useful in the offset collision, but 40% offset collision basically covers the heavy beam well. The heavy beam seems to say, "This is my domain." Opening the door shows a slight indentation on the A-pillar. Compared to other luxury cars, Maybach S goes to another extreme, only one rear airbag. The rear dummy was not used, but the dummies are lively, all restrained by seat belts with minor injuries caused by tightening. Luxury cars doing offset collision tests at this level are heart-stopping, imperfect, and hard to be fully assured. Ordinary cars must be even scarier. There are many cars priced 200,000 to 300,000 yuan, including pure electric Tesla Model 3, Geek 1, NIO ED5T, and Xiaomi G7. Plug-in hybrids include Li Auto L6 and WM Motor M7. Entry-level luxury cars include Volvo S60 and Lexus CS. Among luxury cars, only Maybach S is a benchmark, others have some problems. Asking 200,000 300,000 yuan cars to challenge the 1.48 million Maybach S is unimaginable. Now we are doing Lexus ES's 40% offset collision test at 64 km/h. Foreign tests show great performance with no deformation, but we crashed the strongest car, Audi A4L, which is completely broken. Let's see the first domestic 40% collision result. 101.8. Opening the door is fine. The A-pillar shows a shrink line. Wait, is this weld failure? This is weld failure 1, 2, 3, 4, including another weld peeling off at the A-pillar and B-pillar junction. There is deformation here. From this deformation downward, another weld failure is present. A total of 6 weld points have failed, a craftsmanship defect. According to risk quality control, this should never leave the factory. I don't know where the spirit of the Jiezhou factory went. It's the same car as last time's collision. Low voltage power is now off, hazard lights off, SOS off, relying on backup power. The undercarriage is dripping red fluid. Such severe fuel system leakage should never appear in any collision test. In a real accident, it's very likely to cause fire or spontaneous combustion. The conservative Lexus ES becomes the most embarrassing car in this price range. This Japanese-made imported slippery car's structural performance is even worse than past collisions we did. Not to mention, compared with luxury cars, even low-priced cars fare better. This A-pillar weld failure is unique. Leaking fuel on the floor is unique. 6 weld failures. Bow 2. How many bows should be made to so much spilled fuel? It seems the safest choice is to start with Volvo R460. The entire door ring is still relatively hard. The A-pillar and C-pillar have no cracks or deformation. We can still hear continuous unlocking signals. All 3 are alive. The driver's left leg is slightly over the limit. Why choose Volvo S60 for this test? It's like passing an exam. As long as safety efforts or thought is applied, cars should perform well like Volvo S60. Geek 1 completed the offset collision safely. The padding, occupant structure, and restraint protection all align with benchmarks. From Shanghai Math, all 3 occupants are in good condition. In this test, few cars have all 3 occupants survive well. The last heavy pure electric sedan was close in weight but had very different results. This car's full load reaches 2,720 kg. Structure strength is not worrying. Electric vehicles have large power batteries and more complex electrical systems, posing different collision challenges. Hidden problems like door handle issues have appeared. Hazard lights are off, no voltage. Let's see if the door opens. Without unlocking, no matter how much force, you can't open it. This is very problematic for rescue. Such a case has never occurred before. SOS and airbags rely on backup power to work. Even at airbag deployment, the cabin went completely dark. In rescue, only SOS scores points, other scores are basically lost. Structure and dummy injuries are good, but the power circuit failed significantly after collision, with battery voltage dropping from pre-collision to 0.17 V, almost none. This reminds us of NIO ET5's early recall due to front cabin high voltage line short circuit. Was this problem unresolved or are new problems emerging? Also, NIO ET5T's passenger airbag showed obvious flames. Airbags must not produce visible flames on deployment due to burn risks. Mass-produced cars possibly showing this means batch issues. Both NIO and suppliers need to investigate the airbag problem. NIO's R&D may need to get out of the office. CAE simulation is one thing, real crash tests are necessary. If not for the low voltage power and door lock failure, NIO ET5T's overall rating would be excellent, among the best. What a pity. Tesla Model 3 left rear dummy shows moderate bending injury with some cervical fracture risk. Other injury risks are relatively low. For sedans, structural designs are now comparable, which is why we always replace dummies in tests. As a new brand, Xiaomi SU7 is here. This is Xiaomi SU7's first appearance in such a large-scale safety unit. I'm not worried about structure but about restraint systems, seat belts, airbags and seats working well together. It's the only car like this, so its score may represent the whole automaker's score. Hello, this is Xiaomi Auto Emergency Rescue Center. How can I help you? It's nothing. False alarm. Hazard lights are on. Structure looks sturdy. Can open door. At 124.5 km/h collision, the crash beam did not crush. Everyone should drive carefully on the road as this car's structure is more aggressive compared to most cars on the market. It is definitely hard and heavy, pressing the front shield area. This node may need optimization because a sharp edge might break and threaten occupant intrusion. Key dummy data: the front dummy is near head injury limits, possibly causing brain contusions and intracranial hemorrhage, definitely needing an ambulance. The front female dummy's head and chest injuries are severe due to airbag deployment being too aggressive, likely designed for males with bigger heads and heavier weight, but replaced with a smaller head. Rear injuries are worse on the left due to seat belt use. Right side is lighter but all occupants survive. Airbag deployment optimizations are not something an OTA update can fix. Li Auto L6's problems are also regrettable. Proper crash beam crush. Longitudinal energy absorption box worked well. Base is good. No bending or finger deformation on A-pillar. Structure performance gives strong confidence but dummies seem less confident. Final dummy injury values show rear two dummies have very high chest injury and risk of serious injury. Front dummy chest injury compression is near limit to M level. Rear two dummies' chests reached 1M and 1P level, causing overall downgrade beyond limit with high risk of death, serious injury or disability. The cause is Li Auto L6's rear seatbelts deployed at significantly different times. These two are quite different. Both reached full extension but length difference is considerable. Seatbelt parameters may not consider current conditions or adult male weight. Rear dummies' movement and rebound differ greatly, directly causing injury. Simply put, it's hard. 3 dummies cumulatively broke 5 to 8 ribs. Next is the problem M7. Hazard lights on, unlocked, no need to keep disconnecting. Thanks. Hazard lights, door handles popped out, SOS emergency call works, rescue index is flawless, so far crush zones are normal. Crash beam transfers force downward, airbags did not crush the wheel hub, a pillar slightly compressed, overall structure performance is good, all side airbags and curtains deployed, one airbag buckle split may be a manufacturing issue, both seat belts showed normal deployment. Could it be like some luxury cars where structure is good but occupant protection is poor? Dummy data is clear, fair and open. M7 offers the lowest injury among all rear right dummies, better than luxury cars. Small female drivers seated front are well protected. The restraint system and each configuration are well justified. In this 64 km/h usual condition, performance is quite good. In the 200,000 to 300,000 yuan price range, Chinese domestic brand cars have a reputation for sturdy cabins, with high-strength door rings surpassing joint ventures and even luxury cars in just 10 years, but many cars have regrets in restraint and electrical systems. 100,000 to 200,000 yuan range. In this range, 8 popular SUVs are good household helpers and bestsellers worldwide, including Japanese Toyota RAV4, Honda CR-V, Nissan Qashqai and Volkswagen Tharu. If you have this budget, these are your usual picks. These cars have always traded crude design for hot sales. Global cars have their advantages. Toyota RAV4 still offers relatively good occupant protection but at a cost, no hazard lights and the second battery is now dead. The famous SOS has a backup battery or capacitor. There is a lot of red fluid but engine oil leaked a lot, posing a natural fire risk. The exaggerated movie scenario was replicated in the park in 2024. In the US, is it the same leak or are we just harsher? This year's CR-V occupant protection is worse than RAV4, cannot open hazard lights and lacks SOS. After collision, it quietly and plainly didn't turn on hazard lights. Low voltage electricity is present but hazard lights off. Toyota and Honda don't have hazard lights. If missed, no hazard lights, which easily causes secondary accidents. Shock points hazard lights on. Nissan Shock originally had a complete cabin, but it cut the left rear dummy's neck. In contrast, German Volkswagen Tharu has higher structure and strength, relying on hard body and buffer zones with or without. The price is rear passenger safety. After collision, the front cabin short-circuited and smoked, likely electrical short circuit. This is probably wiring short circuit. Smoke indicates natural risk. This is the second time we see such an issue in Volkswagen collision tests. Last time, fire broke out in 3 seconds. Such hidden dangers easily cause bigger problems in collisions. BYD Song DMI offset collision structure and cabin strength are not great but much improved compared to the toughest old model 2 years ago. Here, a false alarm triggered a test at the A-pillar position. The junction between B-pillar and lower sill at this position has deformation. The front structure puts pressure on the rear cabin. The deformation here is larger than Geely Galaxy. BYD Song DMI's structure scores low but rescue index is perfect. The heaviest injuries appear in 2 places, one due to cabin deformation causing front female dummy's lower leg injury to be P level. The foot plate is seriously crushed. The first area is left rear male dummy's chest and lower leg injuries at M level. Rear occupants are protected by seatbelts with some chest injury values. Currently, all 3 dummies survive, which is better than many models including cooperating brands. Haval Big Dog's structure and rescue rank high in this price range. Front female protection is also good. Rear dummies' injuries are worse. Geely Yinsheng L7 is structurally much stronger than Song but seatbelts do not cooperate well. Hard body causes high dummy chest compression. These 3 models were not purchased but overall are stronger than joint venture cars. Chang'an 4 SQ Plus 3rd generation is different, the only test car with all 3 dummy heads and necks exceeding injury limits without fatal injuries. Dummy head injuries are largely over limits, survival chances are low, the 3 ambulances are inevitable. The obvious problem is restraint systems. This goes back 5 years when CS75 Plus equipped simple seatbelts. After 5 years, low-end CS75 Plus switched to ordinary seatbelts, changing 3 dummies' fate. Cars in this price range have issues here and there in 40% offset collision. It depends on which you can tolerate. What about cars under 100,000 yuan? Airbags, curtains, and safety features are usually incomplete. Body structural steel strength is also limited by cost. All cars are brand new with mileage under 10 km directly pulled from 4S shops. This is the first large-scale open replacement test for globally top-selling cars. Let's see how Chin plus DMI performs in the overall safety index. I see the second battery is working normally, structure matching is poor, the A-pillar and front connection are torn open, the door ring is bent outward, the dashboard shifted backward significantly. Oh, the door opened, the lower hinge column seems failed, many parts are torn, you can't see the metal frame, its front energy absorption is poor, all transferred to the A-pillar. A pillar deformation is severe, seat belt tightness causes some dummy discomfort. Compared to Chin plus DMI, Chin L has the same design. Voltage is normal so hazard lights off. Before both Chin plus DMI and Chin L had hazard lights on, its curtain airbags did not deploy. Let's test door unlocking force can open at 155.6 N. The same issue occurs. Front interference, dashboard falling, interior panel fragments damaging arteries etc. After prying open seals, it's obvious parts of the A-pillar inner and outer panels separated, really moving a lot. Is safety compromised by cost cutting? Rear 2 dummies with non-warning seatbelts pay a high price. Chest injuries are high. Compared to Alibaba family-style structural design, this seems overly stressed, easily pushing car body beyond limits. Also, BYD models share similar acceleration issues with varying severity. Fortunately, a mold can be opened to replicate the problem, which feels very similar. Which interior panel is this? Shouldn't this be the interior panel here? The whole dashboard shifted significantly. The center console was lifted by collision intrusion. The dashboard intrusion was serious, bringing the dummy's head close to it, then the airbag exploded, pushing the dummy backward. For this dummy, injury values are high, likely neck fracture. Leg injuries are also severe. Overall, this dummy is probably lost. Rear 2 dummies still have relatively high survival chances. The A-pillar design is pushed beyond limits again, dragging down multiple BYD models. The A-pillar root deformed. The crack and split caused the dashboard crossbeam bracket to break. With collision intrusion, the steering wheel position shifts greatly, causing excessive injury. The best performing car in this price range is the family-style BRD7 LDMI. Chin plus DMI is better than other models in the same price range. Structure is not great, but occupant protection is stronger than competitors. The worst performer in this price range is Wuling Apple, which has the fewest airbags. Structure is acceptable, but main problem lies with dummies. Only the front female dummy has low injury values. Rear two adult males with only ordinary seatbelts show high head, neck, and chest injuries, with high chance of severe injury and low survival hope. Geely Dahao's structure is average, but due to front body structure issues, injury concentrates on driver dummy. Rear two adult males suffer multiple rib fractures but still have chance to survive. Under 100,000 yuan cars have great challenges simulating self-assembly collisions. Meeting heavier and larger cars increases risk. Fortunately, new energy cars protect batteries very well. Two 7-seat MPVs Buick JR8 and Legend M8, despite different prices, have similar offset collision structure performance. Both utilize buffer energy absorption zones and have similar cabin strength, similarly protecting occupants. First-row dummy injuries are lighter in Legend M8. Legend M8 is the second car in offset collision with door unlocking failure after collision. This door cannot open, force measured at 422.8 N, also a sudden low voltage drop during collision. The 40% offset collision honeycomb simulates real car collision online. Compared to previous crash data, real car collisions of the same grade are more severe than offset collisions. Worse cars perform even worse. After the basic 40% offset collision comes a harder test. Second collision, 80 km/h high-speed rear end. The rear test vehicle is light, under 1.4 tons. The kinetic energy at this speed is similar to a fully loaded large G-Class hitting the rear. Vehicle weight distribution and dummy layout remain unchanged, simulating a secondary accident at the scene. We observe vehicle structure, battery completeness, and fuel leakage. From million yuan cars down to 50,000 yuan entry level, how many experience such collision tests? Let's see their final performance. This is a North American mandatory regulation standard, referencing FMVSS 301. All cars undergo such rear-end collision tests. Most global cars pass without fuel leakage to be sold in North America. But in China, no one can predict how cars will behave after rear-end collision. Recent high-speed rear-end accidents are not rare. Globally, Chinese versions differ inside and out with 3-box or 2-box configurations, batteries catching fire or gasoline spilling everywhere. We are now doing BYD Chin plus DMI's rear-end test. Before the test, all trunks are restored to original condition. I'm not worried about this car's rear end because its fuel tank is under the trunk. China has never done such rear-end tests on Chin plus DMI. Let's see how it performs. It seems red fuel is leaking on the ground. Wow, pouring out. This is a very dangerous accident scenario. Rear-end tests focus most on fuel system integrity. Now fuel system fails first. Steel exhaust and fuel tank scrape the ground, causing sparks and fuel leakage. This is deadly. BYD and China's best-selling cars have relatively thin crash beams and absorption boxes. Rear axle is pushed in, seats deformed. The entire trunk is gone. We are removing dummies. The entire chassis floor is now visible, fully collapsed. The battery position can be seen through the cabin. At the door beam, 2 weld points failed, tearing the unibody. If this happens, the vehicle is basically disintegrated. There was no high-level optimization for such rear-end conditions because all tests use the same driving speed. It's really hard to be soft like this. Many cars have fuel tank and pipe issues. Fuel tanks without rear axle protection leak easily in high-speed rear-end. Compared to BYD Chin plus DMI, BYD Song DMI moved fuel tank ahead of rear axle, which protects the tank in rear-end. BYD Song DMI, Chang'an Origin A05 both leak due to similar layout problems. 2 cars stuck together, leaking heavily. The gasoline smell is too strong. Let's push the test car out and hook it up. The trunk is very heavy. The test car's overall crush is not obvious, but if this happened to a real car, it would likely catch fire. This is a lesson learned in the US where Ford caused many crashes due to this. Then spontaneous combustion and deaths occurred. Now, in 2024, such layouts reappear, which is definitely problematic. Must casualties occur before attention is paid? Also, the same brand's Chang'an 4 SQ Plus fuel tank also leaks, with fuel traces from collision point to here. The chassis bottom is soaked in fuel. At collision instant, fuel sprays out of the tank. This is the first pure fuel car with fuel system leakage. It's also the second failed Chang'an model, very regrettable. The leakage location and parts are the same. The fuel tank has been removed. It's obvious the entire opening above the fuel pump is cracked. The fuel pipe connection here was damaged. The same brand leaks fuel tanks. Suppliers must check which batch is problematic or if it's inherent. BYD Songdmi's rear fuel pipe leaks after collision, showing no consideration for high-speed rear-end. Global cars leak too. Nissan Shock is not sold in North America, so its high-speed rear-end leaks fuel. Fuel system integrity is problematic and must be deducted points. Some cars do not leak fuel, but their body structures cannot withstand high-speed rear-end, exposing ground inside the cabin. Rear axle intrusion is also serious. Its rear longitudinal beam is too soft, fully crushed. The C-pillar deformation is severe. The floor and door sill beams are completely separated. Last time Chin Plus DMI had such floor damage. Havel Big Dog is fully torn and deformed on both sides. I never expected the entire rear seat flipped with everything upside down. The entire rear deformation is among the worst in this test. Luxury cars perform more stably overall. Except Land Rover Range Rover surprises us again with two-level opening doors. The door inside is pushed in. Such a structure is poor for this class. Such delicate rear protection weight is rare in this class. Every seam is wrong. Door gaps are misaligned. The body deformation is severe. The door ring structure is weak. Let's see if the door opens. Can it be judged as impossible to open by hand? The handle is almost crushed. The new Range Rover comes like this but now becomes like this. The rear shows entire downward deformation. The handle can still be pulled out. Both sides have large door gaps. Non-collision door sills have deformation. The test vehicle is under 1.4 tons, a very lightweight test car simulating a small sedan. But the rope is installed like this, which is unexpected. 3 test conditions each show decades-old concepts and technology. 3 test conditions. Coincidentally, we also found some workmanship and craftsmanship flaws. The brand new car's wiring pads have all fallen off. Many owners complain about annoying noises. We consider this an NVH problem solved. After testing Range Rover, it can really learn from Chery on how to improve body assembly craftsmanship. New energy vehicles lack thermal management, but future integrated body may expose hidden risks. The entire rear axle is now broken out. Wow, the weight broke completely, crushing entirely. This strength is very high, but it shattered into pieces. I have never seen unibody crushed like this. After collision, protection elements behind are also broken. It can hardly bear more force. After high-speed rear-end, I didn't expect pure electric vehicles to protect so well. Also didn't expect so many cars to leak fuel. There is a big difference between optimized and non-optimized structures in high-speed rear-end. Fuel tanks under trunks are indeed scary. Our Dongchedi safety index has gone through a long time and finally completed all collision tests. This time, all cars were randomly bought from 4 nationwide 4S shops, which is equivalent to a large-scale spot check. We never displayed collision tests so thoroughly before. We actually saw production craftsmanship problems, extreme cost-cutting, and some cars with very good structural designs. Some brands also had bright spots. Many new colleagues can see much effort was made. Power batteries are complete, and after disassembly, cells are intact. In short, after dozens of collisions in Dongchedi Safety Index, many surprises and gains were found. We hope automakers learn from this. If Chinese domestic automakers want to go overseas, they can refer to this. Our vehicles should focus more on saving occupants' lives in various accidents. This is the original intention. To promote the industry to produce better and safer products. This episode of Dongchedi Experimental Field ends here. See you next time. We also need some positive feedback. Comments supporting us are good. We will persist. Indeed, many mainstream models are not covered yet, such as Tesla Model Y, Tang K300, Equation Report, Extreme Point Yangwang U8, Wenjian M9, Li Auto L7 or L8, plus new Xpeng cars and Honda Accord, Corolla, Camry and Highlander.